Welcome to the webinar EICASLAB Overview. This webinar provides an extended overview of the main key features, tools and benefits of EICASLAB, the professional software suite for automatic control design and forecasting. EICASLAB is able to assist you in all the phases of the control design process, from system concept to generation of the code to be transferred in the final target and final validation test. Starting from the user objectives and the required control performance, you can immediately focus on the system concept, paying attention since the beginning to the functional architecture, both in terms of hardware and in terms of software. Then you can develop the algorithm and the related software of your control strategy, testing them through a like real-time simulation in interaction with the simulated plant. After this first phase of work, you can configure and run on field the rapid control prototyping of your control. It consists in piloting the real plant in real time with an easy-to-use and smart platform called EICASLAB RCP platform, able to get the measurement data from and to provide the control commands to the real plant. During the rapid control prototyping, you can also record all the relevant data for further post-processing and control tuning. Specifically, the data recorded on field allow to perform the offline repetition of the trial in slow motion, acting like a sort of moviola. Then, you can move to the automatic generation and export of code for the final target, enabling the hardware-in-the-loop test, in which the control runs on the final target, in like real-time or real-time, in interaction with the simulated plant, and then moving to the final validation test, in which the plant is piloted in real time by the final target. All the described process can be accomplished in EICASLAB in an easy-to-use, seamless and low-cost way, having at disposal the EICASLAB RCP platform, that is a standard multi-core PC equipped with a real-time operating system and the EICASLAB suite, the final target hardware, and the real plant. EICASLAB provides a set of integrated, easy-to-use and seamless tools for covering all the phases of the control design process. Let's have a quick look at them. You can carry on the plant modeling and control design activities through the Sim Builder tool. The model parameter identification devoted to identify the parameters of the plant model, and the control parameter optimization devoted to optimize the control algorithm parameters are addressed by the MPI CPO Manager tool. The like real-time simulations can be performed by the Sim tool that faithfully emulates the execution of the final control architecture to be designed and that is able to record all the useful data for a further post-processing to be performed with the POST tool. So, the Sim Builder, Sim, MPI, CPO Manager and POST tools in EICASLAB address what we call the modeling and like real-time simulation operative mode or control design phase, because you build and test your project working in an entirely simulated environment. The next operative mode or control design phase is the so-called rapid control prototyping. EICASLAB offers the RCP Manager tool that allows to perform in real-time experimental trials by piloting the real plant with the EICASLAB RCP platform that executes in real time your control code. The slow motion tool that allows an offline repetition of the trials starting from data recorded by the RCP Manager tool. And the MPI CPO Manager tool that still allows to perform the model parameter identification and control parameter optimization for control tuning and refinement in seamless connection with the RCP Manager tool. The last operative mode or control design phase is the so-called target. Here, EICASLAB automatically generates the code to be transferred to the final target and enables to perform hardware-in-the-loop and final validation tests. Specifically, two tools for supporting the designer are available: the Hill Manager tool that allows to perform hardware-in-the-loop tests working with the target and the simulated plant, and the Target Manager tool that allows to monitor the final target hardware that pilots the real plant during the final validation test. All these tools are managed by the Master tool, which is the main EICASLab tool. With EICASLab, you can manage and carry on all the control design phases, not only through the EICASLab software suite, but also working on just one EICASLab project. In fact, you have the possibility to organize your project in more layouts, each one dedicated to manage a specific control design phase, that is, modeling and like real-time simulation, rapid control prototyping, and target. All the layouts are fully customizable in terms of hardware and software interfaces, while they share the same application software related to your control. Let us now start a carousel on each EICASLab tool, starting from the Sim Builder tool that provides a seamless and pre-organized environment for modeling and designing your control strategy. Starting from the requirements, you can conceive the system concept and define the architecture to be implemented in terms of both hardware and software. You can address from simple to complex embedded control system architectures, that is, hardware architectures including multiprocessor controllers, and software architectures including control functions at multi-hierarchical level. To do that, EICASLab offers a set of graphical layouts organized in a hierarchical way, referring to the plant, control, and mission task. More specifically, EICASLab offers three pre-organized working areas, namely the plant area for modeling the plant to be controlled, the control area for the implementation of all the control algorithm, and the mission area for the generation of control references and for modeling the disturbances acting on the plant. With the Sim Builder tool, you can easily apply the two-model approach to design your control. The two considered models are the accurate model and the simplified model, and the two-model approach allows you to test and tune your control algorithm based on the simplified model by assessing its limits of validity through the accurate model. The accurate model typically includes all the aspects not directly considered in the control, such as typically hysteresis and backslash, but that may act on the frequency band of the control affecting your control. It allows you to measure the goodness and performance of your control. The simplified model is implemented for designing the control. It is typically a linear model suitable to design the control. More in detail, in the plant area of the Sim Builder tool, you can implement the accurate model of the plant to be controlled. For implementing the accurate model, Sim Builder provides libraries for specific application sectors, such as automotive, space, economy, robotics, and machine tools. In the control area of the Sim Builder tool, you can implement the simplified model. Let us remark that EICASLab is specifically conceived for directly designing digital controls, and that in EICASLab you can easily apply your own control design methodology as you prefer. Let's have now a look at the available programming modes. Sim Builder offers three smart modes for programming: graphical mode, NCC, and automatic algorithm generation. The wide offer of programming modes available in Sim Builder provides the user with all the flexibility for programming control systems of any level of complexity. In detail, in the graphical mode you can apply a standard graphical approach by drawing your layout based on blocks and connections. Specific library blocks are available, oriented to each area to be programmed: plant area, mission area, and control area. You can also easily customize the block libraries by developing and adding your own macro blocks. In the ANSI mode, you can work on blocks easily programmable in ANSI language by means of an open and customizable preorganized structure that provides a complete set of template files and libraries that allow you to focus on the algorithm to be coded more than on the block interfaces and connections. In fact, the interface between the blocks programmed in ANSI and the rest of the project is automatically managed by SimBuilder together with the compiling task and the user support for error analysis and debugging purposes. The automatic algorithm generation is a special feature specifically oriented to automatically design and generate the complete control algorithm and related software based on a model-based approach that includes the design of a reference generator and or state observer and or closed-loop control. SimBuilder offers a professional approach that enables you to design and test your control, taking into account since the beginning the control architecture in terms of both hardware and software and the related real-time requirements. All the activities of your project can be programmed with a set of initialization functions called just once at the beginning of the activity, two periodic functions, the exit and the out, and a set of final functions called just once at the end of the activity. The periodic functions exit and out are the key functions that enable what in EICASLab is called like real-time simulation. To each activity, you can assign the phase, that is the time at which the activity has to be called for the first time, the period related to its periodical execution, and the duration, that is the execution time considered the worst case. So, the exe function is dedicated to update the periodically activity state based on the assigned phase and period, while the output function is dedicated to periodically provide the output of the activity only after the stated fixed duration. This approach allows to perform the like real-time simulation approach, avoiding wrong time zero simulations. Let us present now the capabilities of another tool, the SIM tool, available in EICASLab. SIM is the EICASLab tool specifically devoted to perform professional simulation with the like real-time technique. It emulates the control architectures designed in SimBuilder. Here is represented the typical flow of the SIM tool based on the activities programmed in SimBuilder jointly with their scheduling data. The SIM tool offers a graphical user interface to monitor during the simulation the variables of your interest. You can see here up to 6 areas fully configurable by the user. In addition, it allows to save on the PC disk all the desired variables of your programmed activities for further post-processing. The post-processing phase is addressed in EICASLab with a specific tool called POST, specifically conceived to perform the post-processing of data recorded both during the like real-time simulation phase and during the experimental trial on field. Let's move now to explain in a nutshell how you can address rapid control prototyping in EICASLab. In literature, rapid control prototyping, or RCP, is a process which lets the engineer quickly test and iterate the control strategies on a dedicated hardware equipped with a real-time operating system and with real input-output devices. The plant under control is real, and the control strategy is executed in real time in a hardware that can be commanded through a host computer where data recording capabilities for tuning and debugging purposes are required. EICASLab implements an innovative, smart, easy-to-use and low-cost rapid control prototyping, in which you can pilot in real time the plant to be controlled through what we call EICASLab RCP platform, that is a PC, desktop or laptop, equipped with a real-time operating system, the EICASLab suite, and suitable hardware interfaces. So, in the EICASLab RCP platform, you can design and simulate the desired multiprocessor architectures, and you can configure the EICASLab RCP platform so to be able to faithfully emulate such architectures, thanks to a smart real-time scheduler that allows you to use the multi-core multi-threading of your PC. With the suite, you can then generate the software code basics software, which implements the programmed real-time scheduler and that is so able to manage the processor clock and the input-output interrupts and to schedule the control functions according to the selected multi-threading and multi-core configuration. At this point, you are ready to connect the EICASLab RCP platform to your plant and to execute the RCP on-field trials. During the on-field trials, the multi-core multi-threading capabilities of the PC are also used to record on the disk all the variables of interest for enabling a further phase of debugging and validation, performed through the slow motion view technique. In fact, EICASLab is equipped with a slow motion tool that allows the offline repetition of the recorded trials, working as a sort of moviola. EICASLab allows an easy configuration of the EICASLab RCP platform in which you can group your activities in threads and assign the threads to the PC cores. The configuration provides a wide range of parameters to manage in real time the EICASLab RCP platform, including task priority, execution in hard-soft real-time, stack dimension, and schedule policy. Thanks to the multi-core multi-threading capabilities, you can emulate also complex multiprocessor architecture during the rapid control prototyping phase. Two rapid control prototyping scenarios can be implemented in EICASLab to perform the RCP trials on field. The standard rapid control prototyping scenario involves the real plant and the EICASLab RCP platform, equipped with suitable interface management for getting the plant measures and providing the commands. The extended rapid control prototyping scenario is useful when the connection with the real plant can be not easily implemented by using your PC. In this case, you can use your final target as a simple bridge to enable the connection of your PC with the real plant. This means that the final target is used just to acquire the measurement from the plant and transfer them to the EICASLab RCP platform and to provide the commands to the plant as computed by the EICASLab RCP platform. Typically, during the execution of an experimental trial, only a limited number of variables of your control system may be monitored or accessible. Slow motion is the advanced tool available in EICASLab during the rapid control prototyping phase that allows step-by-step and variable-by-variable the analysis of the real plant control software run during the experimental trials carried out on the actual plant. In fact, during the execution in real time of the RCP trials, you can configure in the EICASLab RCP platform smart recording procedures that are able to automatically record on the PC disk all the plant input-output and the host command set to the controller. The recorded data can be so processed offline through the slow motion tool, which works like a sort of moviola. With the slow motion tool, you can run your control step by step by using a debugger program for advanced debugging and tuning purposes. Use the slow motion saves time and money in the validation of your control. Once completed the rapid control prototyping, thanks to the features available in the EICASLab HEGRS and HIL modules, you can automatically generate the software code for the final hardware target, and then execute the hardware-in-the-loop test, consisting in piloting, instead of the actual plant, the plant simulated in EICASLab and running on your PC, suitably configured and connected through the necessary hardware interfaces with the final hardware target. So, the main actors of the hardware-in-the-loop in EICASLab are again the EICASLab RCP platform, in which you can execute the dynamic behavior of the simulated plant, and the hardware target, in which you can execute the control algorithm. At the end of this process, you can finally perform what we call the final validation test. managed by the HIL and FVT module. In the final validation test scenario, the target pilots the real plant, but you can again connect the EICASLab RCP platform to the final hardware target and use the platform to provide commands to the target and/or for monitoring the target variables. Again, the main actors are the real plant, the final hardware target, and the EICASLab RCP platform. Let's move to a special advanced feature in EICASLab dealing with the identification and optimization task. Thanks to the EICASLab MPI-CPO module, you can easily and quickly perform the model parameter identification and the control parameter optimization. The model parameter identification adopts an original identification method oriented to estimate the optimal values of the simplified model from the control design point of view. The control parameter optimization adopts a powerful algorithm of numerical optimization that allows in short time to achieve the optimal values of a large set of parameters. The overall identification optimization process is managed by the MPI-CPO Manager tool. Model parameter identification and control parameter optimization can be performed in modeling and like real-time operative mode, where the process is performed in simulation through the SIM tool integrated with the MPI-CPO Manager tool, and in rapid control prototyping, where the process is performed during the real-time experimental trial through the RCP Manager tool integrated with the MPI-CPO Manager tool, or, again, in slow motion, where the model parameter identification is performed through the slow motion tool integrated with the MPI-CPO Manager tool by using the data recorded by the RCP Manager tool during the real-time experimental trial. The availability of model parameter identification and control parameter optimization in rapid control prototyping increases your capability to optimize your control through data acquired from the true plant. Let's now focus on the variety of automatic code generation available in EICASLab. The EICASLab HGAS module provides the automatic code generation for application software that allows to generate the application software, that is a software that implements your algorithm, which is target independent, typically related to the control area, and that is shared between the modeling and like real-time simulation, the rapid control prototyping, and the target phase. The output of the automatic code generation of the application software is a professional and well-readable and clean software code in ANSI language. You can see here an example of the generated templates. The HG for Rapid Control Prototyping Advanced feature allows to generate the complementary source code that is the basic software, based on a real-time scheduler and multi-threading programming techniques, which is target-dependent and able to manage the hardware interface to the real plant. The basic software, together with the application software, provides a multi-core and multi-threading real-time application able to perform a complete RCP test. The HG for the Hardware Target Advanced feature, available in the Target module, allows to generate the basic software that is a target-dependent source code able to manage the hardware target interfaces and the real-time scheduling of tasks in the board that, together with the application software, provides the real-time program for desired hardware target. The HG for the HIL Advanced feature allows to generate the basic software which, together with the application software, allows to perform the hardware-in-the-loop activities. And finally, the HG for the FVT Advanced feature allows to generate the basic software which, together with the application software, allows to perform the final validation test activities. In synthesis, the EICASLab software suite offers you a wide set of benefits. You can work with just one suite and just one project. You do not need a deep mathematical knowledge. You can minimize the time to develop the control algorithm, so reducing time and cost of the control design. You can design starting from plant datasheet only, without setup in field. You have large freedom in designing and configuring. You can increase the performance, especially in complex control cases. The webinar EICASLAB Overview is finished. Thank you for your attention. For any further information, please visit www.eicaslab.com.